In this video, we're talking about how to solve fractional equations. And when we say a fractional equation, we mean an equation, so it has an equal sign in it, where we have fractions on either the left-hand side and or the right-hand side. So let's do a couple examples so we can see how we'll solve something like this. Our first example is 1/2 x, or 1/2 times x, plus 4 is equal to 16, and we want to solve this equation for x. Well, it's always easier to deal with whole numbers than it is to deal with fractions. So our strategy for solving a fractional equation is going to be to eliminate the fraction so that we end up with only whole numbers, and then solve for the variable x once we've got whole numbers only in our equation. So how do we eliminate a fraction? Well, when we have only one fraction, we just multiply the entire equation by whatever's in the denominator of that fraction. So in this case, the denominator is equal to 2. So what we want to do is multiply this entire equation by 2. And what that means is that we're going to have to multiply every term on the left by 2 and every term on the right by 2. So when we multiply 2 by 1/2, the 2's are going to cancel. We have a 2 in the numerator and the 2 in the denominator. Those cancel, and we're just left with 1 times x. 1 times x is just x, so we get x here. 2 times 4 we know is 8, so we'll keep the plus sign and say 8. And then 2 times 16 is 32. So notice how we multiplied 2 across every term in our equation. If you want to think about this as the distributive property, that's really all we're doing. And we're multiplying this 2 by each term in our equation like this. So then, once we've done that, we just want to solve for x. In this case, we need to eliminate the 8 on the left-hand side to get x by itself. We'll do that by keeping our equation balanced and subtracting 8 from both sides of the equation. When we do that, we'll get positive 8 and negative 8 to cancel, leaving us with just x plus 0, or x, on the left-hand side. And on the right, we get 32 minus 8, which we know is 24. So x equals 24 is the solution to this fractional equation. Let's do a second example here where we have two fractions involved in our equation. In this case, we need to find the least common multiple of all of the denominators in our equation. So in this equation, we have two denominators, 4 and 3. Remember, when you need to find the least common multiple of two small numbers, the easiest way to go about doing it is to look at the larger number, in this case 4, look at the multiples of 4, and find the smallest multiple of 4 that 3 will go into. So for example, 4 times 1 is 4, but 3 doesn't go evenly into 4. 4 times 2 is 8, but 3 doesn't go evenly into 8. 4 times 3 is 12. 3 happens to go evenly into 12 4 times, so 12 is going to be our least common multiple, which means we want to multiply our entire equation by that least common multiple we found, 12. Then when we do that, we again want to distribute this 12 across all three terms in our equation on both the left-hand side and the right-hand side. 12 times 3/4, well, we'll do the numerators first. 12 times 3 gives us 36. 36 divided by 4 gives us 9. So we're going to get 9x. Then 12 times 2 is 24, so we get plus 24. 12 times 1/3, well, we'll do 12 times 1, the numerators, that's 12. 12 divided by 3 is 4, so we get 4 on the right-hand side. Now we just want to subtract 24 from both sides, always keeping our equation balanced. When we do, we'll get positive and negative to cancel out, leaving us with just 9x on the left and negative 20 on the right. Then we want to divide both sides of our equation by 9. We'll get our 9's to cancel over here, and we'll just be left with x is equal to negative 20 over 9. And we can't reduce this equation at all because the factors of 9 are 9 and 1 or 3 and 3. And the greatest common factor there with 20 is just 1. So negative 20 over 9 is our final answer. Let's do one more example like that where we have two fractions involved. So again, we have two denominators, one with 4 and one with 5. We need the least common multiple of 4 and 5. So let's go ahead and take 4 and 5 here. 5 is the larger number, so we want to look at its multiples. 5 times 1 is 5. 4 doesn't go into that evenly. 5 times 2 is 10, and 4 doesn't go in evenly. 5 times 3 is 15. 4 still doesn't go in evenly. 5 times 4 is 20. 4 goes into 25 times evenly, so 20 will be our least common multiple, which means we need to multiply both sides of this equation by 20. Now we'll use our distributive property and distribute 20 across all three of our terms. 20 times 2x is 40x. 20 times 1/4 is 20 times 1, which is 20, divided by 4, which is 5, so we get plus 5. And then equal to 20 times 2 is 40 when we do the numerators. 40 divided by 5 is 8, so we get 8 over here. Subtracting 5 from both sides leaves us with just 40x on the left because we get positive and negative 5 to cancel. 8 minus 5, or 8 plus a negative 5, is 3. And when we divide both sides by 40, we're going to get x is equal to, when we get our 40s to cancel, 3 over 40. The greatest common factor of 3 and 40 is just 1, so we can't reduce this fraction at all, and x equals 3 over 40 is the solution to this fractional equation.